All right, guys, so today we're going to look at solving some equations, more specifically quadratic equations. Remember, quadratic means our highest exponent is a 2. So when we're going to be solving our equations today, we are going to have the highest exponent of a 2. So just to start off, we're going to start off really simple. X squared equals 9. We're just going to do a little guess and check. So can you guys think of any numbers that when I square them, the result would be 9?
3.
Okay, let's try 3. So if we think x would equal 3, that's our guess. Now we check it. We put 3 in for x, which would then be squared. Does it equal 9? 3 squared means 3 times 3. 9 equals 9. Yep, 3 would be a solution. But now in part B, it asks, could there be more than one solution that makes the equation true? So are there any other numbers out there that we could square that would result in a positive 9? What do you think? Couple people nod your head. What do you guys think? Throw numbers my way if you have an idea. What else could work? Okay, I heard a suggestion of negative 3. Let's try it. So there's our guess of negative 3. Let's put it in for the x when we square it. So if I square something, it means that thing times itself. So negative 3 times negative 3 does give me positive 9. So yeah, there can be more than one solution when we're solving those quadratics. Remember, quadratic highest exponent is a 2. But now we don't want to have to spend our time guessing and checking. That's going to take a lot of time. Our equations are going to get a little more involved. So what operation could we use? I know we talked about it when we were doing our review assignment. What could we use that could be the inverse of squaring something? Or what operation could undo our square? We talked about when we were working on the review assignment of our first trimester stuff. What could undo the square? What do you guys think? Okay, square root, yeah. If you're not super familiar with square roots, that's okay. We'll talk a little bit today about how to find the square root of a number. So instead of guessing and checking, we're going to try using square roots to help us solve. And today, guys, all we're going to do is we're going to take a look at 6 different examples of solving a quadratic using our square roots, and we're going to call it a day. Okay? All right, so here we go. Let's take a look at example number 1. The idea is with that square root piece, we need to take the square root last. So our goal needs to be, we need to get the squared term by itself first. So anything else that's on the same side as the squared term, we need to get it out of there before we can take our square root. You guys did a lot of equation solving in the first part of this course. Some of it was just linear, some of it was absolute value, some of it where you were solving inequalities. How we solve doesn't change, now just because we're throwing a square in there. How do I move that negative 5 to the other side? Or how do I undo subtraction? What do you think? How do I undo subtraction? Add it, yeah. Add 5 to both sides. Remember, we have to keep our equation balanced. All right, so we add 5 to both sides. We're left with x squared equals 25. I don't know why this thing's freaking out. Sorry, guys. I don't know why it's doing that. There we go. All right, so we have x squared equals 25. Now, we just talked about, to undo the square, we're going to use square root. Now, on that left side, the square root literally takes away the square. It undoes the square. Those two cancel each other out. So I'm left with an x. Now, if I type into my calculator square root of 25, it's going to tell me it's 5. But now here's the problem, though. When we did our guessing and checking up here, positive 3 was not my only possible answer. What was my other one? It could also have been negative 3. So the same thing's going to apply here. I could square positive 5 and get 25, or negative 5. So when we're solving using our square roots, there's the possibility we're going to have two solutions. So we have to keep that in mind. If I put square root of 25 in my calculator, it's just going to tell me 5. We have to keep in mind, if I square negative 5, I also get 25. Now, one little symbol I just want to introduce you to, that's going to come up more next unit for us, but I just want to introduce you to it. A little bit of a shorthand, if your solutions are a positive and a negative of the same number, you can do a little plus minus sign and put the two together. Take it or leave it right now. I just want to introduce you to it. There's a formula that we're going to use next unit that has that plus minus symbol as a part of it. So I want us to see it today. So when we see it next unit, it won't be the first time we see it. All right, same idea continues in question number 2. Taking the square root to undo the square is the very, very last thing I do. So my goal is to get the squared term by itself. In this case, it's x squared. We talked a lot about exponents in our first unit, and we know that the squared part does not go with that 2 coefficient. It just goes with the x. All right, so now same rules apply for solving any of the other equations that you guys have done up to this point. We need to undo our addition first. So we're going to subtract 4 from both sides. Now I know you're like, okay, yep, squared things by itself. Let's do this. The only thing that's being squared is the x. The 2 is not being squared. That big coefficient 2 that's out front of the x, that's not being squared. So we're not ready to square root yet. We have 2 times x squared. How do I undo the multiplying? Divide. Yeah, so we're going to divide by 2. So I have x squared equals 4. Now the square is by itself. Now I can finish up. Now I can take the square root. So all your other inverse operations, guys, those still apply. Undo your addition and subtraction first. Undo multiplying and dividing next. Then do your square root stuff. So we're going to square root. You have your choice of how you want to write your answer. X equals 2 or negative 2. Or you can do the plus minus and put the 2 there. Either way, you don't have to write them both ways. If you don't like the plus minus, if that bothers you, then don't use it yet. It's a little shorthand. And it's something we're going to see next unit. All right, let's take a look at number 3. Now, number 3 is the type of equation that, for some reason, I always get a lot of mistakes on when it comes to solving, although it looks really simple. Our goal is to still get the squared term by itself. I don't want to move that squared term. I want to move the 4 that's with it. How do I move that 4 to the other side? I know there's not a plus or a minus in front of it, and there's sometimes where people get stuck. What do you think? How do I take positive 4 and move it to the other side? To undo the positive, we would have to have a negative, right? So we're going to subtract 4 from both sides. And I know some of you are thinking, Miss Golly, that's not a tricky one. But it is the type, guys, I'll be honest, that I see a lot of mistakes on because there's not a plus or minus in front of the 4 we need to move. So if there's not a plus or minus there, that means we have a positive number. To undo that positive, we need a negative, and that means subtraction. The squared numbers, the squared term's by itself. So we're going to square root. Now the square root of 0, 0 is 0. I can't do plus or minus 0 because really, it's just 0. So don't worry with 0. You're just going to have one answer. You're going to have one solution, and that's it. So for these first three, we treat them just like all the linear equations and inequalities you guys solved in the first part of this course. Do all your usual inverse operations. Undo addition and subtraction first, undo multiplying and dividing next. The only new piece we've added in is we need to finish off, undo the square by taking the square root. Now, in our very last set of examples, same idea is going to hold true, but our squared term looks a little different. Our squared term is no longer just an x. Now it's something like an x minus 2, or we see an x plus 3, but we're going to treat it the same. So my first goal is to get the squared term by itself. Doesn't matter that it has some parentheses with it, that x minus 2 is being squared. I need to get that x minus 2 squared by itself. So how do I get the 4 out of there? What needs to happen to the minus 4? We need to add it over. Yeah, add the 4 over. Add the 4 over. So now we have our x minus 2. It's still squared. And now we're equal to 9. Now we equal 9. The x minus 2, that whole thing is being squared. I can't move anything out of there until I get rid of the square. So to undo the square, we take the square root. Now on that left side, I know it's a little more involved than just having an x squared there. But taking the square root, it undoes the square. That's all it does on that left side. So on the left side, I have left x minus 2. All I have on the left side is x minus 2. I don't have to do anything else. I don't try to take the square root of 2 or x or square root and the square. They cancel each other out. They undo each other. But now the square root of 9 though. The square root of 9, we have to think about what we did in questions 1 and 2. The square root of 9 could be positive 3. The square root of 9 could be negative 3. So when this situation happens, this is a lot like when you guys solved absolute value equations. When you guys solved absolute value equations, you had to consider the positive case and the negative case. And that's the same situation we have here with our square roots. Now to finish off, just add your 2 to both sides. So if I can relate this to anything that you have already done, is when you solved using absolute value. When you solve using absolute value, you have 2 cases, that positive and that negative. Because the absolute value, one number has 2 different numbers that can have the same absolute value. So positive 3 and negative 3 have the same absolute value. Just like positive 3 and negative 3, if you square them, give you the same square. So now number 5, you're like, well, Miss Keller, there's a lot going on number 5. There is. If it helps you, if you notice I keep drawing a box around that square part, if it helps you to do that, to put a box around whatever's being squared, that might help you see, hey, this is what I have to single out before I can do my square root. So the thing that has the box around it, treat it as if it were just a plain old x you wanted to solve for, like you did in the first part of this course, and when you solved equations in 8th grade and maybe even 7th grade. I need to undo the addition and subtraction piece first. So in this case, undo the subtraction by adding. Everything else stays the same. Nothing else has changed yet. Now, I know it's really, really tempting. We see a negative 3 in front of a set of parentheses. So I know it's really tempting to want to distribute. I can't distribute though because of the square. Order of operations says you would have to do the exponent first before you could multiply. So I can't distribute because of the square. So now I have to think about, I have negative 3 times x plus 3, that quantity squared. So to undo the multiplying, we're going to divide by negative 3. Now, I know some of you are thinking, Miss Callie, that's going to make things really messy. Nope. The negative 3's on the left side are going to simplify to 1. I don't have to do anything with what's ever inside those parentheses. I don't do anything with the x plus 3. The negative 3 simplified down to 1. Now what I have left is the squared term by itself. It's ready to rock and roll. Now we're ready. Squared terms by itself. Now we're ready for square root. Remember, taking the square root just undoes the square. So we're going to be left with x plus 3. But that could equal positive 4. X plus 3 could also equal negative 4. When I take the square root of 16, again, if you're not real good on what the square root of certain numbers would be and you throw that in your calculator, it's just going to tell you 4. Subtract 3 from each, and our solutions could be 1 or negative 7. Now the reason why I say or is because I can't put 1 and negative 7 in for x at the same time. I could put 1 in as my solution, or I can put negative 7 in. I can't put them both in at the same time. Now today I did get asked the question on Miss Callie, so do we need both answers? Just like absolute value, the answer is yes, you need both. So you need that positive case and that negative case. All right, guys, we're on our home stretch. We're on our last example already. Number 6, again, the goal is to get that squared number by itself, or squared term. So once again, we have a number in front of those parentheses, the negative 2. But remember, I can't distribute because of the exponent. Okay, order of operations would tell us we'd have to take care of that exponent first before we can multiply by the 2. And that sounds like way more work than what we want to do. So to undo negative 2 times that square, we're going to divide. The negative 2 simplify to 1, so then I'm just left with x plus 3 squared. And I have equals, don't forget the negative on your 36. Be careful with your signs. As we're going to see in a minute, our result being positive or negative does make a really big difference. So the squared term is by itself. Undo the square by using square root. And we're going to get x plus 3 equals, square root negative 36. My calculator tells me it's an error. It says it's a non-real answer. Well, but the square root of negative 36, why isn't it just 6? Why doesn't that work? So this is saying if the square root of 36 is, what number squared would equal negative 36? Is there a number? Well, if we try 6, 6 squared is positive 36. Negative 6 squared is also positive 36. So here's the issue we run into. I can't find a number so that I can square it and get a negative 36. So if you're solving your equation, you come across the square root of a negative, and here's why it's so careful to watch your signs when you're doing your adding, subtracting, your multiplying, dividing. You have to watch your signs because we can't find the square root of a negative. So I'm going to make a little note here. Square root of a negative number is a non-real answer. So we would just simply write no solution. Now you might be like, Miss Guy, why'd you say non-real answer? The number system we work with, guys, all the positives, negatives, zero, decimals, fractions, all those things are part of what we call the real number system. Numbers like the square root of negative 36, they dip into the set of numbers that we call the imaginary numbers. Imaginary numbers are something you learn about in Algebra 2. This is the only little plug that I do about them. For our purposes in Algebra 1, we cannot find the answer if we're taking the square root of a negative. So we just say we have no solution for that. So now, just to summarize a little bit, I just want to do letter A, because letter B really says the same thing. I don't know why I typed both parts there. It seemed like a good idea when I was planning. Now, did we always get two solutions? So let's see. In number 1 we did plus or minus 5. Number 2 we did plus or minus 2. But in number 3, how many solutions did we get? Just one. So what causes one solution? Well, square root of 0. It only has one possible answer, and that's 0. So, do you always get no solutions? Square root of 0 gives us just one solution, and that's always going to be the case. If you go to solve and your final step is to take the square root of 0, you're only going to end up with one solution. But now only if it's your final step. If you've got like x plus 3 squared equals 0, you're going to end up with more than one. But the square root of 0 can give us one solution. And then number 4 can give us 2. Number 5 gave us 2. But then number 6, though, let's see. On this one, I'm going to put a little thing, C number 3. I'm going to put a C number 6. And the square root of a negative gave us no solution. Otherwise, if you're solving using square roots, you will get two solutions. So the only things that could possibly give us less than 2 would be those of them that involve the square root of 0 and the ones that involve the square root of a negative. Those are the only ones you won't get 2 for. Otherwise, you should have 2 every single time. And then part B pretty much says the same thing. How many could they have? We could have 0, 1, or 2. We could have 0, 1, or 2. So any of those situations could happen. The most common is that you would have 2. The most common is that you would have 2, but the other 2 do happen as well.